We're here to talk through this Kakuro puzzle by Murat and Tonta. It's on a hex grid and it's also themed on black hexagon, and you can see the six clues forming a hexagon here. So it's quite an impressive construction with these evenly spaced clues. And the first thing I want to note is I'll be using the candidates tab because I find that more comfortable. So now looking at the puzzle itself, I look at this first, this intersection of 3 and 4. In regular Kakuro, it's pretty common to get started off with, and it forces this. Now, because of the hex grid and its properties, this cell is actually seen by all of these three. And since it's a 10 sum, it has to be 1, 2, 3, and 4. And 2 and 3 can't be here, and 1 also can't be here. So this is a 4. Now, this 6 sum can be either 2, 4, or 1, 5. But this cell can be neither 2 nor 4. So it has to be 1 or 5, and you can't have a so this is a 1 5 pair, and you can't have a 5 over here because that would break with the 10 sum, so you actually end up forcing this. So similar to what we saw here, this cell over here is now seen by this 2, this 5, and this 1, and since it's 11 sum, we know that it's 2 3 5 that's remaining, so you get a 3 here, and 2 and 5 go in these two cells. And we know for the 10 sum, 2 and 3 go in these two cells. Now for this 30 sum, if this is a 2, then this is 2 and 3, that sums to a 5. The maximum possible in these three cells is 24, but you need 25 if it's a 2 and a 3. So that actually means there's a 5 here and a 2 here, and that resolves this as well. Now you have these two cells summing to 7, and the remaining three cells have to sum to 23. So 9 can't be here as well, and 9 can't be here as well. So 9 is here, and the other two are 6 and 8. Now I look at the top left corner, and I see the 16 sum. You know it's 7 and 9. So this 9 is looking at this cell. So this is 7 and 9. And this is a 6. Now because this is a 6, this becomes an 8. This becomes a 6. So the next thing to see here would be this cell right here, because it's 6 sum. It can't be a 2, so it's a 1 4 or 5, but it can't be a 5 either because that would lead to a 1 here, which is too small for this 11 sum. So you can't have a 5 here, and this is a 2 or 5. Now this is either a 6 or a 9 because of this, but it can't be a 9. So it's actually a 6, this is a 5, and this is a 1. Now this cell, this 12 sum over here, it can't have 1, it can't have 2, it can't have 3, and it can't have 5 or 6 either. So it can only have 4, and these will have 1, 2, and 5. So this is a 1, 2 because there's a 5 here, and 1, 2, and 5 over here. Now, if this is a 5, you would have a 3 here, which for the 8 sum, which breaks with this 3. So the 5 goes here. And also now you can't have a 2 here because there's a 5. There's a 5 over here, and a 5 can't come here. So you end up having 1 and 6, and 7 here, and this resolves this. So now if we look at this sum over here, right? So what's remaining over here is, so there's 2 and 6 are gone, and 3 and 7 are gone. So it could be a 1 or a 5, and this cell would be a 3 or a 7 because of that. So 7 goes with 1, 3 goes with 5. And because of this 10 sum, this would also be a 3 or 7. But because of the 3 here, now we can resolve all of these. And now this cell becomes important because now you can see that it's seen by a 2, it's seen by a 3, it's seen by a 4, and it's seen by a 5. And this is a 15 sum, so nothing higher than a 5 can come here. So this is a 1. Now we can look at this diagonal, which is almost the diagonal row. It's almost completed. So there's 1, 2, 3, 5, 7. So there's 4, 6, 8, and 9 remaining. Since 6, 8, and 9 are in this row, this will be a 4. And since 6 and 9 are in this row, this will be an 8. And 6 is looking at this cell again, so this will be a 9. Now let's just mark these for the 15 sum. So this is going to be a 1, 4, or 5. This is going to be a 1, 2, 4, or 5. I don't think this is restricted yet. And this is going to be a 2 or 3. So I think only 3 sums are remaining. This one the 18 over here, and the 13 over here. Now the 13 is interesting because there's a 5 already. So the remaining has to sum to an 8, and it can't be 1, 2, and 5. So it's 1, 3, and 4, out of which the 4 looks at this and this set. So 4 comes here, and this is 1 or 3, and this is 1 or 3. Now let's look at this row because it's almost completed. So 5, 7, 8, and 9 are remaining. So there's 7 or 9 here, then there's an 8 or 9 here because there's a 5 and 7. And here there's a 5, 8 or 9 because there's a 7 over here. But it can't be a 9 because that's too high for the 18. So the 9 goes. Now, if this is a 5, then what happens is you will either need, so you need 7 for these two cells. It will either be 1 and 6, which breaks, or 3 and 4, which also breaks. So this can't be a 5, it's an 8. That resolves this full row. And it also shows us that these two cells now sum to 4. So it has to be 1 and 3. So the 1 comes here and the 3 comes here. And that forces this to be a 2 as well. So actually shouldn't have marked the 1s, but it's okay, we saw it now. So now I look at this diagonal, and what's remaining is a 1, 2, 1, 2, 4, 5, I think. 1, 2, 4, 5, and 9. So this can't be a 4, 5, 9, it can't be a 2 as well. So this is a 1. Now this can't be a 2 and 9 either. So this is a 4 and 5. And this one can be a 2 or 9. Now let's look at this cell because it's almost, there's so many digits looking at it. So there's a 1 and a 2, there's a 3 and a 4 and a 5, 6, 7, and 9. So this is an 8. Now looking at this row, what's remaining is a 1, 4, 5, and 7. You can't have a 1 here, so it's a, you can't have a 4 or 5 either because these are looking at it. So this is a 7, and this is a 1, 4, or 5. But because we have a 4 or 5 pair over here, what ends up happening is 4 or 5 cannot come here and it cannot come here because it would block out both of these cells. So this is gone and this is gone. Now let's look at this cell. So interestingly, all 1, 2, 3, 4 are pointing at it from here. 5, 6, 7, and 9. So this is an 8. And then if you look at this cell, 1, 3, 4 are pointing at it. 5, 6, 7, 8, 9. So this is a 2. That makes this a 9. So let's look at this one. I see all the odd digits pointing at it, and there's 2, 6, and 8 as well. So there's a 4, and that resolves this and finishes the puzzle. So what we saw here was some of the borders got solved first. The easy 2-cell clues got resolved, and that helped us. But most of the solve path from the middle of it onwards just was more about understanding the properties of the hex grid and using uh, the row and column constraints of it in a very interesting way. So thanks Murat for the puzzle, and thank you all for watching.